you start making new pictures, you want somebody there who can assess how that affects the output of AI. So I think that's a great example. And yeah,
Great.
I will make sure we share the presentation as well. Thanks, everyone.
Thanks. I think you've done half my presentation for me, so I'll keep it brief. Just somebody confirm you can see my slides, and then I'll move straight on.
Yeah, we can.
Excellent.
Go ahead.
All right. I'm going to make them next. All right. So this is basically a bit of history as well. We went back through the history of AI, but this takes us all the way back to cyclones Ida and Kenneth, and I'm sure a lot of the people in the room were present during Ida and Kenneth. Those were the two cyclones where WFP first used drones in an emergency, or at least first officially used drones. And so our role was to create maps of all of these areas that were most affected. And I'm going to go through some of the images. This is the before images are all taken from Google Earth, from satellites, which is why they're a little bit fuzzy. And we can see the damage afterwards with the drone imagery, which is also a lot more crisp and clear. We could also go back and do remote assessments of things we missed. So if you were checking if there was connectivity on the island and there wasn't, and then you wanted to know if any of the cell phone towers were still standing, you might not have noticed it on the day, but you can always go back to your drone imagery and you can go and check these out. And we can zoom in a lot as well. So unlike a satellite image where you can see, okay, things were damaged, but the structure in the middle still looks like it's got four walls standing. What was that structure? With drone imagery, you've got the ability to zoom in and see a school in this case. And then somebody came up to us and said, great, you guys have all these maps. We can go and look at things manually, but how many structures were damaged? And myself and the team, and I know we've got Antonio Velez on the call there, we're sitting around and thinking, well, let's see if we can count them. And I started counting them on one of the days, and at the end of the day, I think I've reached about 1,300 structures that I've counted. And there were 60,000 structures in the city of Beira, so we quickly realized this is not going to be a task we're going to complete in any usable amount of time. And that's when we realized we needed to do things a little bit differently. So, I mean, this is the typical sort of 72 hours of a disaster. You have the impact, you collect as much data as you can, you try and do the analysis and processing as well as possible so that you can guide the response. Now, we had a challenge. We knew we wanted to do it with computing power. And nowadays, there's AI tools all over the show. But in 2019, there weren't a lot of AI tools around. So there was a project in our organization from Google called Sky, and they were doing pretty much the same thing. We were trying to automate damage assessments. The problem was when you arrive in an emergency location, we don't have the ability to send multiple gigabytes of geotiffs up to the cloud to be analyzed by a supercomputer in the cloud. We typically have very little internet bandwidth, as you all know. Nowadays, it's slightly different because Starlink is around, but in 2019, you're lucky if you can get a few images out and not multiple gigabyte worth of files. So we decided to develop our own tool, which doesn't run on the cloud, the digital engine for emergency photo analysis. It's called Deep. And Deep is basically an offline tool that can run on nearly any hardware, so it doesn't require 12 GPUs that can mine Bitcoin in its spare time or anything like that. It will run on, initially we designed it to run on a gaming laptop, but after that we actually designed it to run on a normal laptop, your office laptop. It takes a little bit longer, but it still completes the job. And to give you an example, a single drone flight will analyze with a NVIDIA GPU-powered laptop or a gaming laptop. It takes about 5 minutes, but I'll do the same analysis on my office laptop, which has no GPU, or at least a built-in GPU, and it'll take me about an hour, so we get the answers as well. And then most importantly, it needs to cost nothing. We need to be able to get this tool into as many hands as possible, because we don't want to be flying around with high-powered laptops to go and run some analysis. We'd like the engineers on the ground to be able to do this analysis themselves. That's what they're doing at the moment. So how does Deep do it? So we uploaded GeoTIFF to Deep, and we've had it trained on multiple sets of data, dominantly the cyclone data from Kenneth and Ida, but a number of other data sources as well. And the first thing it does is it tries to identify buildings, or at least the structure of a building, or the footprint of buildings.
Patrick, sorry, your audio is fading a bit. Could you speak closer to the microphone, please?
Sure. How do you hear me now? Sorry, I'm in a bit of a
This is much better.
bandwidth restricted environment. Okay.
This is better. Thank you.
Thank you very much. So the first thing it does is it identifies every structure on the ground, whether damaged or undamaged, and it circles the footprints for us. And then through an unsupervised model, now unsupervised is important in this case because we don't have time in an emergency to train a model for the specific environments. So an unsupervised model goes on all its previous trainings and tries to do a damage assessment to see whether a structure is damaged or not. And instead of talking a little bit longer, I'm going to play a video, but I've realized I've committed one of the crucial mistakes in a presentation. And I've shared my screen without sharing my audio. So give me 1 minute to share my screen with audio. Include audio window. All right. Going back to presenter view. And now we should hear it.
The use of drones alongside DEEP gives us a new way of how we're responding to emergencies today, particularly in countries like the Dominican Republic in the Caribbean that suffer from climate shocks. It helps us improve in agility and accuracy, particularly in the first phases of a response where we most need it.
So Hurricane Fiona was the first official use of DEEP. And we were quite fortunate. We'd actually been training the National Disaster Management Agency about 3 months before Hurricane Fiona hit. So they were able to fly the drones and to collect the data and do what was needed on their own. They told us that the areas that were assessed using drones and AI, which took us about 48 hours, including operating the drones and analyzing the data, would have taken them about 3 weeks to do on foot. So it's a significant amount of savings. And it scales incredibly well. Normally, when you scale an area you want to cover sort of manual processes, you scale it, time increases by the square of the size. But with AI, you don't really notice the difference until you get to very, very large areas. And that's one of the great things about it. To date, this is where WFP has used it, not our partners. We've done 5 emergencies. We've published a number of papers. We've done a lot of trainings and given people the ability to use both drones and the AI tool DEEP, which is part of our training. So one thing I forgot to mention is DEEP doesn't only run on drone data. It also runs on high-resolution satellite data. So if you've got sort of 3 meter and below satellite data, you'll have absolutely no problem running it on that as well. And then the lessons learned. The first thing is that when you're developing a tool, you need to know the emergency context. So for us to have somebody sitting in San Francisco connected to sort of the fastest internet around the world and every cloud tool available, building a tool for emergencies is probably not going to be something that's going to be practical to use on a day-to-day basis. It would be far better if you design it to run where there may be no internet and sort of only regular computers floating around. Drones are great. I've worked in drones for about 6 or 7 years now, but until AI came along, drones could only do so much. A picture might tell you a big story, but if you don't know how to analyze those pictures, you don't have the ability to analyze those photos quickly enough, you can't turn the data into information. And this is where the key came for us in using AI. And then preparedness, obviously having people on the ground who know how to operate drones or access satellite data as well as do the analysis with AI is massively important. And so we found that building local capacity is probably giving us the best return on investment on on these tools and tasks. There is another AI tool that WFP has been using for a couple of years now, which is one of the other success stories besides Deep. I won't play the video. It's not emergency related. It's a photograph analysis tool used to deduplicate identities. When we're dealing with our beneficiaries, we often have beneficiaries registered in multiple locations or with multiple projects, and this tool allows us to identify where these duplicates are. I've got the QR code on the screen. I'm also going to post the link in the chat later if anyone wants to check it out, if there's time for one of the breaks, and I will end my presentation there. So thank you very much.
Thank you, Patrick. Thanks a lot. Yes, and I invite everyone to actually check that link as well. I see a question from Pan. Real quick, go ahead. Then we'll move to our next speaker. I can't hear you just now. Pantanda, you want to raise a point? Question?
I'll check the chat as well if there's any questions for me, and I can answer them
let's
later.
do that. Well, we'll try to put the question at the end of the Q&A, since some of what will be presented, the other use case might be have similarities to what you just did. So let's move on with Jose Cobos from Data Friendly Space. There's actually a lot on what they are doing online. If you don't know what Data Friendly Space is and does, but they've been working with us in the assessment analysis cell for several years and supporting the work we do while we are on the field. So Jose is joining us today. He's the head of partnership and innovation at the DFS, Data Friendly Space. Jose is the driving force behind the use of AI and natural language processing in humanitarian context. His work focuses on making data more accessible and actionable for responders, especially in the complex emergency and displacement settings. So you can see him on the screen. He's with Eric from NARA, so sister unit here in